Hi, physiology students. This is kind of an extra video to help understand Lab 3 a little bit. I know Lab 3 is a little tricky because we're working with spectrometry and measuring absorbances of different lights. So I'm going to take you through what you guys are expected to do as a part of your lab report, and then the different kind of resources that you can use to help with that. So we have, first of all, everything up until this point before the lab report, you do not need to fill out or do any graphs. The plasma protein data, I give you the data of Robert's, Fran's, Robbie's, and Terry's sample. And if you look at the PowerPoint on here, and if you download the PowerPoint from the module, these are the protein plasma values of the 4 patients. And keep in mind that normal values of protein plasma are about 6 to 8 grams per deciliter. So you can see that a couple people are out of the normal range. But what you need to do for the first part of your lab report is literally, and again, I'm going to show you back to the lab report and go down, and I'll come back to this plasma glucose data because I'll show you how to use that to make a graph. But for the plasma protein concentration of Robert, Fran, Robbie, and Terry, you literally just copy and paste the data that I give you from this PowerPoint. Robert is 3 grams per deciliter, Fran is 9, Robbie is 9, and then Terry is 7. And keep in mind, I give you little hints here what a low plasma protein concentration could mean, and it looks like Robert is out of that range on the low side, and what a high concentration protein plasma content could mean, and it looks like Fran and Robbie are just outside of the normal range on the high end. So keep that in mind because you'll use that to answer some questions. But that's how you just put in information for Robert, Fran, Robbie, and Terry, copy and paste those values right from the PowerPoint. The plasma glucose concentration levels, this is where we kind of use our spectrometry background as much as we can, as you could gather from the first lab video, to answer these questions. So how do we get the plasma glucose concentrations of Robert, Fran, Robbie, and Terry? Well, we have to use this plasma glucose data to create a graph, and I'll show you what I mean by that. What spectrometry is it's kind of shining light through a sample at a different concentration and then measuring how much light is absorbed. So for example, we first have some standards, some kind of controls that we can kind of gather first of all, and we will measure the absorbance of light for these different standards. So how much light this concentration is absorbing, or this concentration, or this one, or this one. We can then plot a graph, and then we can kind of plug into that graph some random plasma samples from a patient, for example. So we have Robert, Fran, Robbie, and Terry again, and we have measured out their absorbance levels of their plasma glucose concentrations. And using the standard graph that we'll plot, we'll be able to kind of estimate their glucose level concentrations on the graph. So with that, I'm going to take you to a graph page. So what you'll need to do is plot standards versus absorbance. So we want to kind of make a graph, first of all, of like our standard or control. It's kind of like our guide that will help us then figure out what the glucose concentrations are of our patients. So I've done this already in Excel. So in Excel or on a different graph, and if you need a little bit of help remembering how to graph data, hopefully this video will help with that. But here are our standards and their concentrations, and then how much light our standards absorbed. So if we graph this out on the y-axis, which is the axis that goes up and down, these are our absorbance levels. And then the standard concentration levels are on the x-axis. So you can see here at a standard level of about 60 in concentration, that absorbed about 0.2 or 0.19 in amount of light. And our next data was about 120, and I'll make my graph a little bigger, so maybe this will be a little easier to see. So around 120, we have another point that absorbed about 0.42 of light. Here's our third point of about 240 concentration, absorbing about 0.81 in light. And then our next kind of control point was at about 480 in concentration of the standard, and that absorbed about 1.6 light. So we graph this out as kind of our standard graph, and we always create a line that goes through the point of 0, 0. And that's very important that it starts at 0, 0, and then goes up through the points in a linear manner as best fit as we can. So that we always have that 0, 0 starting point is essential, because at 0 concentration, if there's no substance in a sample, then it should not absorb any light. So that's why this line should go through 0, 0 as well. So then we have our samples of our patients. So for example, Robert, his sample of glucose concentration absorbed 0.52. So what we have to do is, when we get to this graph, is we have to go up to about 0.52, which is kind of where my cursor is. And we go over, we kind of make a horizontal line over. Let's see if I can draw in here just a point. So let's say this is where Robert's sample is, where my black dot is. And then we're going to just draw a horizontal line over to the line, the graph line of best fit, and then draw down. And this amount of concentration, this should be Robert's sample. So I'm just going to write an X right there. So remember, Robert's, they give us that absorbance level. So the amount of light that his sample absorbed was about 0.52. We draw a horizontal line over, a vertical line down, using the line of best fit as our guide. And this value right here will be Robert's concentration level of his glucose. So you can estimate this the best you can. I would say it's a little bit more than halfway between 100 and 200. So I would maybe guess this is 160, 170. So you put 170 as the concentration of Robert's glucose level, and you put 170 in your lab report for the plasma glucose concentration level of Robert. That is 170. And you can use your PowerPoint again, as I show here. Normal blood glucose levels are between 70 and 110. And if anyone is too high, they might be diabetic. Or if there's too much insulin, they might have a low blood glucose concentration. So again, as we're working through, you can use my graph if you want to, but it'll help if you kind of make your own. Let's do Robbie's, for example. So we'll go down to Robbie. His absorbance level was at 1. So I'm going to draw in his absorbance level, right, is at 1. So that's where his sample absorbed that much of light. Let's draw, my horizontal line is a little shaky. Let's draw a horizontal line over to our graph and then down. So Robbie's glucose concentration is about 300, and that's way out of normal range. So for Robbie, in your lab report, his glucose concentration is 300. So in your lab report for Robbie, you would write Robbie 300, and these are in always milligrams per deciliter. So find the glucose concentrations for Fran and Terry using that method. And then based on their plasma protein and glucose concentrations, match each patient with a condition. And you'll have to do a little bit of research about this. I tried to provide you with some hints. For example, in the PowerPoint, there's, if you go through and work through the PowerPoint and read through it, we have the different plasma glucose levels, and diabetes mellitus would be high glucose concentration, and oversecretion of insulin would be a low glucose concentration. And I give you normal blood glucose concentration levels. So any one of those patients that falls out of that range, you can use that. And then plasma data I have here, if you have a high protein concentration, you could be dehydrated because you're holding water in the plasma. And if you have a low plasma protein concentration, you could have liver disease or some sort of infection. So use the information in the PowerPoint to then match up based on the data, which person would match up with these kind of 4 issues or problems. And then for the lab report questions, answer these 1 to 4 as best you can. We didn't talk a lot about osmotic consequences. But answer the questions 1 to 4 the best you can, but I'm really going to be focusing on if you can match up the patient data based on their concentration levels of protein and glucose with which person has a specific problem. So hopefully that helped a little bit. Let me know if you guys have more questions. I'll have office hours at 8 a.m. on Thursdays, but I'm happy to meet with you at a different time as well. So good luck, guys, and thanks for listening to the recording.